Okay, welcome back. Gonna finish this up today. I've got in front of you a nice image from a metallurgical microscope of some of these microstructures slash microconstituents that we've been talking about earlier this morning. And what we've got here is a really good example of some proeutectoid ferrite, which is all of these white areas here. Okay, this proeutectoid ferrite. And then that laminar aggregate known as pearlite right here, and all these black and white layers. And see, these are all pearlite, whereas this is all the proeutectoid ferrite, which means that all of this proeutectoid ferrite was formed again above that A1 line. And so, let's see. I got starting of the timer. At any rate, so you can see how they're just dispersed here, all of these different grains. So these used to be the remaining austenite grains prior to it just going below that 1333 degree temperature. And again, this is a really good representation of that. Now this next image is similar, but this is a little more specific to showing the actual, this is on to the right, or the hyper-eutectoid steels. This is showing massive amounts of pearlite here in all these areas. And then just the beginning precipitate out along these grain boundaries shown right here. But again, this is a really, really good image here of a pearlitic structure. And again, it kind of looks like a thumbprint or a fingerprint in there. Okay. Now, these are good black and white images, of course, but I think I have something, Exhibit A, that might show it a little bit better. Let's see if I can bring Exhibit A in here. Okay, now most of you, this may just look like a plain piece of red cabbage, purple cabbage. However, if you turn it over, what do we see? Well, what I see is some proeutectoid ferrite, all these white areas dispersed in amongst all the purple areas, right, being the proeutectoid or the cementite. So this is 100% pearlite structure, right? So this would be, when I take that back, this is actually, since this is 100% pearlite, this is going to be just eutectoid ferrite, these white areas, and the purple areas was just called the cementite or the Fe3C, iron carbide. Okay, so this again is a wonderful round, of course, picture of microstructure of 100% pearlite and a piece of red cabbage. There you go. You thought it couldn't be done. There it is. I'll consume that later. Okay. Now what I want to do is go over a problem, an analysis problem, similar to the one we did with the eutectic drawing earlier. And so I want to do it now with a iron carbon diagram. And so let's bring it back down to full this red and white. Okay. All right. So here we are. And so what we're faced with right now is we're going to determine the relative amounts of ferrite, cementite, and pearlite microconstituents. And we're going to do this from a diagram. I'm just going to draw a partial diagram of what this is going to look like. And so if I do, essentially what we've got going here. So this is going to be, of course, gamma. This is going to be alpha plus All right. So what I'm going to do is we're going to take a point on this drawing, and it's going to be just below the eutectoid temperature, just below this A1 line. So we're going to pick a point about right here, just below, and then this is going to, we're going to call this 0.35% carbon. So that's our point right there. All right. And so what we want to determine is the fraction of the total ferrite and cementite phases. Total fraction of the total ferrite and Fe3C or iron carbide cementite. All right, we want to do that. And then the second one we want to do is the fractions of proeutectoid ferrite and pearlite. The total fractions of proeutectoid ferrite and pearlite. Okay, and then the last one, the fraction of eutectoid ferrite. Fraction of just the eutectoid ferrite. All right, so we'll call this A, call this B, call this C. Okay. All right, so for the first one, they're wanting to know, and again, it's all about, now this is our point, so it's just, we're going to call this just, it says just below. This is at just below 1333 degrees, which is our A1 line. Okay, so we'll call it, 1332 maybe. All right, so so we want to know how much of total ferrite and total cementite is in this region right here. So our tie line would go to here and all the way back over to here, which remember that was way over there at 6.67. And this, of course, is at our 0.025. Okay. All right. So now, what we want to do, let's just find the total. Let's do it this way. The total ferrite. Total ferrite and tectoid, or no, actually just all the ferrite. All right. Okay. To do that, we're going to take, since this is a two-phase region, and this is the alpha, of course, and over here is the Fe3C. Way over here at this 6.67. We're going to take the opposite leg, so that's going to be at our composition, which is 0.35. All right, or 0.35. So it's going to do a lever rule. Our 0.35 minus our 6.67. 6.67. Okay. And then we're going to divide that by the entire length, which is going to be our 6.67 minus our 0.025. And these are going to be approximate numbers. These will be very close. Okay, and so when we do all that, and of course we multiply times 100, we're going to come up with roughly, approximately, and this is very approximate, 95%. All right, so down here we have 95% of alpha grains down here. Okay, that's eutectoid. That's all eutectoid, and if we have, obviously going to have some up here in proeutectoid, but that's all alpha grains. Okay, that's total ferrite. All right, which are alpha grains. All right, and then of course to find, because it has conservation of mass, we just need to subtract, to get the remaining Fe3C. Also, we got to do the total Fe3C is just going to be 100% minus 95%, and of course we come up with 5% of iron carbide. Okay. Now B is the total fraction of proeutectoid, ferrite, and pearlite. Okay. Now for this, we're going to have to do something. We want the total fraction of proeutectoid. The only way we can find that is to go up here to just, and I'm going to put this in a different color. We want to move up to just above this A1 line, to just barely below here. And that way, when we do this diagram, when we do this tie line from here to here, and of course this is going to be at 0.08, and this is 0.025, we're going to find exactly how much proeutectoid ferrite is there. Okay, so to do that, then we're going to take and do our tie line here, and so since we want the proeutectoid ferrite with the opposite leg, so it's going to be the 0.35, and so this is total proeutectoid ferrite. All right, this is going to be equal to that 0.35, which is right here, back to our 0.8, minus our 0.8, divided by the entire length, which would be 0.025 minus our 0.8 times 100. And this again is going to be very approximate, and this will give us roughly about 58%. Roughly about 58% is the proeutectoid ferrite. All right. Now, to do the pearlite. All right, the pearlite. Well, the pearlite is going to be whatever remains here, because if you remember back on that diagram, whatever austenite remains, just as it goes below here, it's going to turn into pearlite. So essentially what we can do is just take, and because again we have conservation of mass, we know it's going to be 100%, so we can just subtract from 100 and come up with basically 42%. So total pearlite would be 42%. Okay, so therefore at just below A1, the total pearlite is going to equal the remaining gamma or austenite at just above the A1 line. Okay, but we had to go up there to find this out, so then we can just subtract from there. Therefore we can subtract 100% minus the 58%, come up with 42% of going to equal pearlite. This is going to be pearlite. Okay, but it's the same amount that is above here in this diagram of austenite is going to decompose into pearlite. So that's what we're saying. So we're just going to take this number and then transport it right back down there, and that's the pearlite number. Okay, and then finally then from part C we wanted the fraction of the eutectoid ferrite. All right, so we already know that we have 95%. We have 95%. 95% is the total alpha, total ferrite. Okay. Now we know that we have 58%. We have 58% of that. 95% is proeutectoid. So if we just simply subtract the 58% from the total, which is this is the proeutectoid, then what we're going to get is the remaining, which is going to be 37%. 37% will just be the eutectoid alpha, and I'm going to put that within. That's going to be within the pearlite structure. Okay, so that's how we got the remaining eutectoid alpha, which is inside this pearlite. I was just subtracting it from the 95% because we found out the 58% here, right there, is the total proeutectoid ferrite. So subtracting it from the total 95% will come up with 37%, which is just the eutectoid alpha. But again, that is from the that will be inside the pearlite, within or inside the pearlite structure. Okay, so that's a good representative type of a analysis, again, on this type of diagram, looking for the total fractional amounts and of the various phases that are forming as the temperature falls, and then we go back up, and we're able to use both of these two phase regions to determine those fractional amounts. And so we got the fractional amounts of total proeutectoid ferrite, all right, which is right here. This is the total proeutectoid ferrite, which is right here. We got the total pearlite, all right. The total pearlite is right here. And then the total amount of eutectoid alpha is 37%, okay? 37%. All right, so the total ferrite then within this whole, at this point, just below there, would be the 58 and 37 added together to come with our total ferrite of 95%. All right, so this will conclude the instructional part of this video, and I will, as we wait for this to be uploaded, you will probably get an email instructing you about the exam. But I will tell you right now, it is tentatively and most likely scheduled for our class time this coming Thursday. That would be the 9th of April at our class time, which is 9:30, and you'll have from 9:30 to 11. And it will be on, the exam will be administered on Blackboard. So I will give the instructions to that and send you an email here in just a little bit. So we'll talk to you soon.